sediment microbial fuel cells, when you're making electrodes, you have to create a solution that's going to coat the electrodes in film conductivity. So to make that solution, there's 4 compounds that we're going to need. The first 2 is PVDF powder and NMDMAC. So what these compounds do is, this is a plastic powder and this is a solution. So the first step is going to be that there's going to be certain proportions of these mixed, and you'll have directions that will show you how to make those, and then you can scale those up for however many electrodes you're going to make. So you'll mix these 2 together in some kind of beaker, and then you'll stir that solution for about 4 to 5 hours. You can basically just judge once all the plastic has dissolved in the solution and it's just a clear liquid in the beaker. That's when you know that it'll be ready. And so after that happens, you're going to also add carbon black and activated carbon. And one thing you should note in terms of safety, you always have your lab coat on, your safety glasses, and your gloves. But when you handle these 2 solutions, since it's very thin granulated carbon, you should also wear some kind of dust mask to help prevent breathing in the particles.
So Brian, I have one question. So they're used for anode or cathode?
These are actually used for both the electrodes.
Okay,
So
good.
you're gonna, for one single microbial fuel cell, there will be 1 anode and 1 cathode. So the proportions will be doubled for all 4 compounds.
Okay, very good.
Approximately 8 milliliters that you're going to need for the NMDMAC. Since it's liquid, you want to use one of these pipettes. So to use this, you're going to stick the needle down inside the container and you're going to spin upwards. And then you're going to fill to approximately however much you need to fill. For this, I'm going to do approximately 8.5 milliliters. So that means this is 8 right here. So I'm going to go about halfway up to that mark right there. One of the things that's important to do is when you're using these, never turn it sideways. You always want to hold it vertically. And always remember to look at the bottom of the meniscus when you're filling the container. And then when you are ready to release, put it in the container and just simply click on this valve. And then at the end, you can slide this back down, and that'll help get the last drop out. There we go. Is to mix the PVDF and the NMDMAC together. So first, you want to put in the stir bar, because we're going to be stirring this using a magnetic stir plate. And then you simply have to mix these together. As I mentioned before, you want to stir this for about 4 to 5 hours. You can see that the powder is floating inside the beaker, so basically you have to wait until all the powder has dissolved. So what you have to do, you put it on the stir plate and then set it to about a medium setting. And then you can let that run. Electrodes, before you add the coating of the solution, you also have to make sure that you cut the wires and attach them, because the wires are going to have to connect to the resistor. So there's 2 different side wires that you have to cut. And these are approximate lengths, but I would suggest doing 8 centimeters and 14 centimeters. 8 centimeters is going to be for the electrode that's floating in the water above the sediment interface. And then the longer 14 centimeter length is going to be the one that's buried within the sediment, so you have to make sure it's long enough to reach above the water. And so what you do is you cut the lengths, and then it's a very thin wire, so you have to be very gentle with it. But you can stick right down in this little area. You can stick the wire down there, and you can cut it through there. And then once you cut it, using that same area, you have to gently trim and strip the wire ends. And sometimes it may take a couple tries, especially when you're first doing it. But that's what the end goal is supposed to look like. So you're going to do that on both ends of the wire, and you're going to do it for both wires that you cut as well. I said, sometimes it takes a couple tries. And in that event, connecting the wires to the electrodes is you're going to take silver epoxy. Now there's two different types. There's one that's epoxy adhesive, and this is also an epoxy adhesive. There's two different shades. One is a thicker component, one is less thick. So you're just going to dab a little bit onto a little tray. Sometimes it takes a little bit to get it out. Just take a little bit of each, and then you're going to mix them together. See, the shinier one comes out a little bit faster. So then you can use something like this to stir them. Just want to make sure they're stuck together really well. Now you do have to work relatively quickly because there's only a limited amount of working time with these. So what you're going to do is you're going to take a little bit of epoxy and you're going to take the wire and you're going to attach it and connect it like this to the cathode or anode. And then you're just going to coat the wire and stainless steel mesh connection. And sometimes you just want to put it all over the electrode or the wire tip. Sometimes the wire doesn't want to stay down, but you just have to kind of play with it a little bit, and eventually you're going to find it where it'll be stuck in position. Just like that. And so you're going to connect one wire to each of the anode and the cathode, and you want to make sure it's closer to the end because the diameter of the electrodes are almost the same size as the cylinder container.
I'm Kevin Bowie.
Electrodes, you have to let the epoxy sit. And there's two different ways of doing this. One option is that you can use some kind of heater or some kind of oven, and this is not one that you would use food in because there's chemicals being used. But for this type of epoxy, you can do 15 minutes at 65 degrees Celsius. That's roughly 150 degrees Fahrenheit. So you can let that sit, and then you can just put it in as soon as you have the wires and electrodes connect together. I would suggest putting it on some kind of aluminum foil so it's not just sitting on the surface of the oven. Another option, especially if you're at home and don't have some kind of heating device that isn't going to be used for food, you can actually just let it sit at room temperature for 24 hours, and then the epoxy will seal, and then your electrodes and wires will be connected just like that. So once you pour the carbon block and activated carbon in, really quickly you're going to stir it up. You're going to make a nice thin solution, and this is where you need to have the mask on just to make sure that you're not breathing in any of the powder as it comes up. Shouldn't be too much, and you should eventually get to a nice thick, soupy black solution. Occasionally you may need to add just a tiny bit more of the NNDMAC, but you should get a nice viscous texture like that. That's what you're looking for. So once you finish stirring, what you're going to do is you're going to take one of the electrodes and you're going to take this out and you're just going to start coating one side entirely. And it doesn't have to be neat, you just have to do it and do it relatively quickly before the solution dries out. Obviously, it's very important to be wearing gloves here because this is not a chemical that you want to be getting all over your hands. Completely coated the electrodes with the solution of carbon and PVDF solution. Then what you're going to do immediately is you're going to put the electrodes in the distilled water. And you're going to let them sit inside the water. And you don't have to wait for them to be dry, you can just put them in right away. And you're going to let them sit there for 15 minutes. And what this does, it induces phase inversion. And that's going to help the solution that you coated with the electrodes. It's just going to become a solid, hard solution that's not going to come apart. So that's the next step. You have to let them sit for 15 minutes, and then once you finish, you can take them out. You can use some kind of tweezers to pull them out of the water if they're at the bottom of the beaker. And then what happens then is you let them sit for 5 to 6 hours, and you just let them air dry. And usually it's good to do that in a fume hood, so that you're not letting any kind of loose chemicals, spray out into the room or anything like that. So just let them air dry for 5 to 6 hours. Sometimes it's best to do that overnight if you're at the end of the day. And then your electrodes are completely made and you're done. Electrodes completed, you're ready to actually construct the sediment microbial fuel cell. These are the containers that we use. Now there are different containers, and it's really up to you what kind of configuration you want to use. But the simplest solution to do is you're going to start, and there's little tick marks drawn on the side of the cylinder to help you find where the areas are. So you're going to first put in 2 centimeters thick, a layer of just the mud that you've collected at the bottom. And then after that, you're going to put in the cathode. Now this is the electrode with the longer wire, because it has to reach all the way to the top of the jar. Now once that electrode goes in, then you can put another thick layer of mud. Now this can be anywhere from 4 to 6 centimeters. Again, this is your call determined by what configuration you're going with. Now this is about roughly the mark that you want to reach. And then once that happens, you're going to take 2 small 0.5 microliter centrifuge tubes, and you're going to stick those into the mud. What that's going to do is it's going to create a platform for the anode to rest in the water layer above the sediment. You don't want the anode to rest in the sediment, because then it's not going to create the redox reaction to the maximum ability that it can. So once you stick the 2 centrifuge tubes in over the mud, just slightly above the top layer of the mud, you're going to put the anode in. And then after that, you're going to add about 2 to 3 centimeters of distilled water. Basically, you have to add just enough so that the anode is completely submerged in the water, but above the mud. And then that is going to be your sediment microbial fuel cell, and you can hook it up to the multimeter, and then you can start recording data, and you're done. Sediment microbial fuel cell completed and ready to test for voltage. You can use a computer and a multimeter to determine how much voltage you're actually producing. So there's a program on the computer, it's called LabVIEW, and what you're going to do is you're going to open it up, and there's going to be different files on the computer. Now, these correspond to different multimeters right here, and these multimeters are labeled. You can see on the blue tape, the top one is labeled K2000-3, this is K2000-4, this one is just K2000, and this is K2700. The K stands for Keekley. This is the type of multimeter it is, and the newer one is the bottom one is a slightly newer model, but they all work the same way. So what you have to do is you just have to find a corresponding file. Now the top one right here, the most recently opened file, is K2000-3. So since we're going to use the top multimeter, we're going to double click on that file. Now the first thing we're going to do is we're going to leave the baud rate at 9600. We're going to change flow control to none, and then termination char is going to stay at CR. Next thing you have to do is click on the VISA resource name, and this computer is hooked up to the top 2 multimeters, and K2000-3 is the one we're using, so we're going to use that. Now the next step is you're going to hit Control-E on the keyboard, and that's going to bring up this flow panel. Now there's different things that you can do here. You can change the name of the file that's going to be produced, and that will be open to there will be a file and a folder on the computer, and it'll come up as a text document. Now one thing that's important is when you're looking at the data, you have to copy and create a new file. You have to copy the file that's produced, because if you open up the file while the data is recording, you're going to corrupt the data, and you're not going to be able to record any more data, and it's going to stop the experiment. So always make sure you can copy and paste the file before opening it to view the data. Another thing that you can do here is right here, this value that says 300,000, this is actually the number of milliseconds that is going to record the voltage. So this is set to every 5 minutes, and that's a pretty good data point to look at. You can look at the voltage every 5 minutes. So my recommendation is to leave it at that, but you can also look at different types. Now, once you have the program set to run on your computer, you have to make sure that the multimeter is hooked up to the sediment microbial fuel cell. Now, one thing that is going to have to happen is you're going to have some kind of resistance as well. And what you're going to do is, we don't have the fuel cell right here visible, but what you'll have is you'll have the alligator clips, and then you're going to attach the clips for the anode and the cathode, and you're going to attach them them using these clips to the wires that come out of the top of the fuel cell. And you'll know the cathode is positive, the anode is negative, so red is negative, or red is positive, black is negative. So make sure you follow that so that you're not going to get negative voltage produced. And then once you have that, you can connect the multimeter using these wires to the alligator clips and the resistor box. And on this resistor box, you can see there's different types of resistance settings. So you can set it to 1,000 ohms, just like that, and now your resistance is set to 1,000 ohms. So once you have all that set to go, you can close out of the block diagram. That's what this screen is called. And then you can click this arrow right here, and that will start recording data. So now data is being recorded. Now this is an error because I didn't rename the new file. So once you are doing your research, you're going to rename the file. But once you have a renamed file, then you won't have to worry about that issue appearing. And then once you are running, if you want to stop recording data, you can just click on that, the abort execution button. Right now it's not running, so I can't click on it. But in the situation that you would be using it, you can do that. And the voltage will be displayed on this diagram right here. It's not connected to anything, so that's why there's no voltage. But hopefully you'll be getting about 500 to 600 millivolts is what you should